Hey guys, if you're new here, I'm April and welcome to my academic series. Today, we are going to cover the topic History of Microbiology. First, we will get to know the father of microbiology, Leeuwenhoek. Leeuwenhoek was the first person to publish accurate observations extensively on microorganisms. He was also the first to develop the simple microscopes, composed of silver plates that hold the double convex lenses. Leeuwenhoek's observations was mainly in regard to protozoans and prokaryotes. Now, before going forward to father of modern microbiology, let's go back in time to know what ancient people believed about creation. Their belief was that in spontaneous generation of organisms, that living organisms developed spontaneously from non-living matter. Even the greatest minds of the time, like Aristotle, believed in the same. They thought that rats developed from straw and clay in agricultural fields, things like that. It's really interesting to go deeper into spontaneous generation theory, but let's move on with the connection of spontaneous generation and microbiology. It was Louis Pasteur, father of modern microbiology, who resolved the conflict over spontaneous generation theory through the famous swan neck experiment. Let's go through the swan neck experiment. First, he placed nutrient solution in flasks and observed microbial growth. Then he placed nutrient solution in flasks again, but this time he heated the flask necks in a flame and drew them into a variety of curves like in the figure. The conditions Pasteur made sure was that the swan neck of the flask were open to the atmosphere. He observed no growth in the nutrient medium in swan neck flasks, but when the beaker was exposed to the atmospheric air, growth commenced immediately. This way, Louis Pasteur, father of modern microbiology, resolved the controversy behind spontaneous generation. He pointed out that no growth occurred because dust and germs had been trapped on the walls of the curved swan necks. Also, he is the one who proposed the famous germ theory. Next topic is microorganisms and diseases. Earlier people believed that diseases were caused by supernatural forces or poisonous vapors or imbalances of the four humors in our body. This myth was resolved by the germ theory that the microbes causes diseases. Evidence for germ theory came from four people, mainly Agostino Bassi, M.J. Berkeley, Heinrich D. Bari, and Joseph Lister. Agostino Bassi's contribution was that he proved that a silkworm infection is actually a fungal infection. Berkeley, who proved the causative nature of water mold in great potato blight in Ireland. Heinrich D. Bari showed the causation of cereal crop disease by smut and rust fungi. Joseph Lister's contribution is a standalone for the germ theory. He worked towards preventing wound infections. Lister developed a system of antiseptic surgery specifically developed to prevent microorganisms from entering the wounds and causing infections. Lister also used a few more methods to prevent infections, like heat sterilizing the instruments before and after use, using phenol over surgical dressings, and also spraying it over the surgical area for preventing infection. Let's move to Koch's postulates. Koch created the experiment to demonstrate the causative nature of bacteria. He worked with mice infected with anthracis. Koch injected fluids from infected mice with anthracis to healthy ones, and the healthy ones ended up dead. Results from these experiments helped him make the criteria to conclude the pathogenicity of bacteria. These criteria for categorizing pathogenic microorganisms came to be known as Koch's postulates. Koch's postulates are there. They are: the microorganism must be present in every case of the disease but absent from healthy organisms. Second, the suspected microorganisms must be isolated and grown in a pure culture. Third, the same disease must result when the isolated microorganism is inoculated into a healthy host. The same microorganism must be isolated again from the diseased host. Our final topic for today is discovery of viruses. An outbreaking invention that paved to the discovery of viruses is that of the porcelain filter by Charles Chamberlain. Specialty of this filter is that bacteria are not able to cross the filter. Ivanovsky and Bejernik are the two scientists working at the same time to find the causative agent of mosaic infection in tobacco. They identified that even after filtration, the plants have caused infection in healthy plants. This made them conclude that the causative agent was smaller than bacteria as they passed through the porcelain filter, and they identified it to be virus. This is how viruses were discovered. Eventually, viruses were shown to be tiny acellular infectious agents. That's for today, my friends. We'll meet next day with our topic classification of microorganisms.